Okay, guys, just want to do a quick video on some questions regarding the reflection of light. Okay, so let's say if I have in this figure, you see some rays hitting a mirror here. Okay, what are some of the terms that we encountered? Basically, AB, which is you can see is perpendicular to the plane, is known as a normal. Okay, RB over here is known as your incident ray, that's right. So incident ray comes in and then BS will be the reflected ray, okay? And MN, what's MN? I think just now we mentioned is basically the plane mirror or the surface. Angle RBA, you can see over here, angle RBA is known as my angle of incidence and angle SBA over here is known as my angle of reflection. All right, so there are two laws of reflection. First and foremost, the incident ray, reflected ray, and normal, all of them will lie in the same plane at the point of incidence. Okay, basically what they are saying is that this was basically 2D. You can't, if you have it in 3D, this law doesn't really work that way. Okay, so the second law is that the angle of incident is equal to the angle of reflection. Okay, as you can see here, angle of incident equals angle of reflection, right? Okay, just like when you play, I'm sure you've played one of those pool games when you were younger. Um, so if you were to hit a ball towards the surface, it will bounce at exactly the same angle, provided you draw a normal to the surface. Okay, next one. The car registration number is this one. If you see in the rear view mirror of in the rear view mirror of a vehicle in front of the car, what will you see? You will see everything to be laterally inverted, but still upright, right? So basically everything will be laterally inverted. In other words, what's on the right will appear on the left and so on. Okay, question 4. Complete the diagram on the right to show the path of the light ray as it is reflected by two plane mirrors. Okay, so the first one you need to do is if you were to draw this down, what do you actually need? Okay, you need a protractor. That's right, because okay, you have a normal here. So if this is angle of incidence of 45 degrees, what you do is just draw the angle of reflection to be, that's right, 45 degrees also. Okay, so then just remove the protractor and I'll put the draw on a normal on the other mirror, and you're right, put the protractor back again, and angle of incidence 45, you notice here, so it will be the angle of reflection will also be 45 degrees. Okay, so what can you use this device for? This is basically used in a periscope, for example in a submarine ship. Okay, and used in submarines to keep a lookout over high obstacles, like example in the wall. All right, question 5. If an angle between an incident ray and a plane mirror is 35 degrees, let me just draw that out for you. You've got a plane mirror here. So there's an incident ray. Where did it say the angle is? Between the ray and plane mirror. So 35 degrees is boom, okay, over here. Okay, but just take note, we got a normal here. So if they say this is 35 degrees, what's the angle of incidence? You are right. It cannot be 35 degrees because our angle of incidence based on our previous videos have to be measured from the normal, okay, which is 55 degrees here. So it's 90 minus 35, it should give me 55. So angle of reflection will be the same as my angle of incidence here, right? So which is works out to be 55 degrees also. And this is a question that we sometimes like to ask, which can be a bit confusing. What's the angle through which the light ray is turned? Okay, so the original incident ray you can see is over here. It turns here. So how does it turn? It actually turns by a total angle of how much? Over here, can you see? It turns 110 degrees. Okay, all right, 6. All right, what you see here is two plane mirrors over here at an angle of 100 degrees to each other. If a ray of light incident strikes it at 45 degrees to the mirror at an angle, so you got to be very careful here. They say 45 degrees to the mirror. That means this is my 45 degrees, right? So if this is my 45 degrees here, what can you see if I were to draw a normal here? Yes, because this is 90 degrees, this one here will be 45 as well, okay? So the first question was the angle of incidence. This will be 45 degrees, right? Okay, so I will have also after the incident ray here, it will be reflected here, and the angle reflection, basically based on the law of reflection, it will be equal to the angle of incidence, which is 45. So since this is 45, the other angle over here will be 45 as well, right? So if this is 45, oh, this is where it gets a little bit interesting, because can you see this triangle here formed by the reflected ray? Yeah, so this closed triangle, what does it mean? That means all the three angles should add up to, you are right, 180. So this angle here will be 180 minus 100 minus 45, which gives me 35 degrees. So if I were to draw back a normal here, this one will be 55 degrees. So to complete the ray diagram, this will be the completion of the path. So the part C will ask you, what's the angle of reflection at which the ray leaves the second mirror? So this is the first mirror, the second mirror, and you are right. Boom. Okay, it should be equal to the angle of incidence, which is 55 degrees, right? All right. So question 7 is another interesting question. I have a boy 1 meter tall standing in front of a large mirror as shown. They ask us to draw rays to show how he can see his head and his toes. In other words, what's the minimum height of a mirror for him to see the reflection of his whole body? Okay, so the first step here is we need to draw a horizontal line all along the way from his head to the mirror. And then we draw the next horizontal line from his eye to the mirror. In other words, we are dividing um, the light rays into two main sections. One is above his eyes and one is below his eyes. So above his eyes, what does he see? You are right, he sees from the top of his head, and from below his eyes, he will see to his feet, right? So just looking at above the eyes, if I have an incident ray and a reflected ray, you are right, it should meet all the way exactly at the center. So I draw a line here, a horizontal line here, splitting into two parts. I call each of this part X. So if each of this part is known as X, then I can, if in other words, I split the top part into two, right? I can actually draw the angle of incidence, and or rather the incident ray and the reflected ray, such that the angle of incidence equals to the angle of reflection here, right? Okay, so I do the same to the bottom part. I just split it into two, but this time I called it Y on each part, and I draw the incident ray from his feet to the mirror, boom, and from the mirror back to his eye, boom. Okay, so this is the incident ray and reflected ray. Okay, so now can you see it's pretty clear? So what is the minimum length of mirror required? I actually don't need the top part and I don't need this part here at the bottom, right? So in other words, I just need this x plus y, which is half of his height. That's it. So that's the minimum height of a mirror. Okay, pretty straightforward. All right, and now question 8. I got a figure below showing the arrangement of two mirrors here. So I got two mirrors, so parallel rays from two different points on distant object behind the observer are incident on one of the mirrors. Okay, so what it says is that the objects are here. Okay, so how do I draw actually the path of light rays? First thing I need to draw, okay, I need to find out, since this is the angle of incidence of 45, I boom, I draw one 45 degrees also, and I do it to the next incident ray, so boom, 45 degrees. Okay, so after that I just move my protractor down, do the same, since this is about 45, I boom all the way and boom again. Okay, so you can see 45 degrees. And what can be said about the image seen by the observer? It is inverted. Okay, all right, so this one here, the diagram below shows two light rays from an object P incident on plane mirror M. So first thing, complete the diagram to show the path of the rays after reflection from M. So after reflection, so the first thing, use reflected rays to locate the position of the image of P. Okay, so I will gonna draw the normal first. After drawing the normal, you can actually put the protractor here. Make sure you can see this is about 28 degrees. So I just draw the same, draw the reflected ray, repeat to the other ray as well. So you can see as if I were to extend this backwards, what happens? They intersect at a point, and that point is, you are right, my image. Okay, so that's how we actually draw, right? Okay, last question over here. The diagram below shows a narrow road with a plane mirror. I got a plane mirror here, mounted at a corner of a 90-degree bend. Point C represents a car approaching the corner. So mark on the diagram the position of the image of the car formed by reflection at the mirror. Okay, so I gotta mark the position of the image of the car. So how? So the image of the car here will be somewhere here, right? Because light travels, when I see light, light appears to travel from a straight line. So I just extend it all the way, and same thing as the previous question, boom, I get intersection point, and that is my image. Okay, so the second part, they ask you to draw the paths of two light rays from C. So I just draw this to all the way from C to the mirror. Okay, so draw an arrow on the diagram to show the direction at which the image of the car appears to be traveling. So the image appears to be traveling towards, because as this goes up, this image appears to go closer, right? So that's it. Okay, hope you guys enjoyed this video. See you guys soon.